So, hi again. So, we're going to continue our discussion all about homogeneous differential equations. So, for the previous video, we solved only two problems, but now I think we'll solve three problems, additional problems, so that we would be able to master homogeneous differential equation. And so, for today, we're going to solve some three problems again. And here is our given problem. Y multiplied by 2x squared minus xy plus y squared dx minus x squared quantity 2x minus y dy is equals to 0 when x is 1 and y is equals to 1 half. So obviously we have a given condition. So the problem is asking for a particular solution. So again, if we recall, okay, we have two substitution here. From the previous video, I've shown you if m is simpler, we're going to let x is equals to vy. If n is simpler, we're going to let y is equals to vx. Okay, in this case, we have this our m as a function of x of xy dx and n as a function of xy in dy. So as you can see here, n is simpler. So we can let y is equals to vx and dy is now v dx plus x dv. Okay, so if we let y as vx, we have vx, we have 2x squared minus x times vx, okay, plus b squared x squared, okay, b squared x squared dx. So we simply substitute the value of y in this term, and the same for our n function, okay. So we have 2x minus vx, and our dy is simply equal to v dx plus x dv. v dx plus x dv, okay, is equals to 0. Simply, we simplify 2x squared minus vx squared plus v squared x squared. We have dx, okay? So, I'm not going to include first the negative. So, I'm going to multiply this by this. So, we have 2x cubed, okay, minus vx cubed multiplied by v dx plus x dv is equals to 0. And again, if I'm going to multiply this, okay, distributive. So we have 2vx cubed, okay, minus vx times vx squared. That should be v squared x cubed plus v squared x squared times vx v cubed x cubed dx minus, okay, I'm going to distribute this onto this. 2x cubed times v dx is simply 2vx cubed dx, okay. 2x cubed times x dv, you can also perform FOIL, okay. So 2x cubed times x dv is plus 2x raised to 4 dv, and this one to this one we have negative v squared, okay, x cubed dx, and finally the last negative vx cubed to x dv is negative vx raised to 4, okay, dv is equal to 0. So if I'm going to distribute the negative sign here, so let me just copy this first. We have this following expression for our m. Okay, if I'm going to distribute this, negative 2vx cubed dx minus 2x raised to 4 plus v squared x cubed dx, I'm only distributing the negative sign. So plus vx raised to 4 dv is equals to 0. So can we simplify this expression or equation? Yes. As we can see here, we have 2vx cubed multiplied by dx, and we have negative 2vx cubed multiplied by dx. So these two, together with the dx also, will cancel because this is multiplied by dx. So this should be cancelled. And of course, we have negative b squared x cubed. We have positive b squared x cubed dx, both in dx. So definitely that would cancel. Okay? So is there anything else? We have b cubed x cubed, negative 2x raised to 4. Okay? Well, this is in terms of, I forgot to write the dv. We have a dv here. Okay? So there's nothing more. So if I'm going to rewrite b cubed x cubed dx minus 2x raised to 4 dv, okay, plus vx raised to 4 dv is equal now to 0. So what are we going to do here is to simplify as much as possible or eliminate the common factors in our equation. So in this case, we have x cubed. We can split off x cubed also here. We can split off x cubed here. So we can divide both sides of the equation by x cubed. So if we're going to divide that, our resulting equation would be we have v cubed dx minus 2x dv, okay, plus vx dv is equals to 0. And if we wish to combine the like terms, so that I'm going to rearrange this as this, vx my dv minus 2x dv is equals to 0. So this should be b cubed dx. I can factor out both dv and x in here. Okay? So if I do that, I could factor x. Okay? That should be v minus 2, and then the dv is equals to 0. Okay? So this one is the same as this. Okay? So, is it a variable separable now? Yes, it's a variable separable. We can group the terms in dx in terms of this side of the equation and the v in this side of the equation, so that we can rewrite this as dx over x plus we have v minus 2 dv over v cubed is equals to 0. Okay, we simply multiply both sides of the equation such that we're going to eliminate, if you didn't get that, okay, such that we're going to eliminate, we want to eliminate v cubed here, so we want to divide the whole expression by v cubed. And I want to eliminate in this term the x, so multiplied by x. Okay, so divide by x, I mean. So the resulting equation would be this. Okay, so, and the great thing is we can now integrate after separating our variables. So what will happen here, integral of dx over x is simply ln of x, plus we can use the properties of integral here. We can separate the numerator, okay, v cubed dv minus, I can factor out 2 outside of the integral sign because it's a constant. So dv over v cubed here is equals to 0. So if we try to integrate this, okay, before integrating, make sure it's simplified. We cancel out v here. So plus, this should be what? 1 over v squared, okay, minus 2, okay, dv over v cubed is equals to 0. So if I'm going to raise this integral or integrand as v raised to negative 2, we have a dv here, of course. V raised to negative dv minus 2 integral of v raised to negative 3 dv is equals to 0. That is simply power rule. So what will happen? ln of x plus, okay, v raised to negative 2 plus 1 over negative 2 plus 1, okay, minus 2. So v raised to negative 3 plus 1 over negative 3 plus 1 is equals to c. Okay, we have integrated. So we can write c on the other side of the equation. Okay, so we have ln of x plus v raised to negative 2 plus 1 is v raised to negative 1 over negative 1. Okay, minus 2. Minus 2, then we have v raised to negative 2 over negative 2 is equals to c. So as you can see here, we can bring this back down so that the negative exponent would be eliminated. So this is divided by negative 1, so this would be minus negative 1 over v. So as you can see, these two would cancel. Negative 2 over negative 2 is positive 1. So we can bring down this also by getting the reciprocal. So we have 1 over v squared is equals to c. Okay, so we can still simplify this. Okay, if we multiply both sides of the equation by v squared. So if we multiply both sides of the equation by v squared, we have v squared ln of x minus v plus 1 is equals to, okay, this is cv squared. If you multiply a variable in the constant c, you should always include that. Okay, so if you multiply constant with c, it is always C. But if you multiply a variable in our C, you should be able what? To still write this. Okay? So you should multiply it as it is. Okay? But V now is equal to what? So we have used in our substitution, we have used y is equals to Vx. So if y is equals to Vx, then V is now equal to y over x. So if we substitute y over x in our V, so what will happen? Y over x, we have squared ln of x, okay, minus y over x plus 1 is equals to c y over x squared. So if we simplify this, we have y squared over x squared ln of x minus y over x plus 1 is equals to c y squared over x squared. Okay, so if we are going to multiply again this such that we're going to eliminate x squared, we multiply both sides of the equation by x squared. That's right. So if you multiply both sides, we have y squared ln of x minus, okay, x squared divided by x is x. So we have x to y here plus x squared here is equals to c x squared times y, cy squared over x squared. This should cancel. So we have y squared in here. Okay. So as you can see here, we have already the general equation, okay, for our differential equation. We cannot cancel ln, okay, because all of the x terms and y terms are not into a natural logarithm form. So this would be, we can consider as our general solution. But that is not the answer yet. Okay, that's not the answer yet. We in the problem we are given with an initial condition when x is equals to 1, y is equals to 1 half. So at x is equals to 1, y is equals to 1 half, we're going to solve for the value of c. So substituting this class, so what will happen? 1 half squared ln of 1 minus 1 times 1 half plus 1 squared is equal to c times y squared. Okay, we simply substituted the value of x and y in our general solution in order for us to find the constant of integration. Okay, the constant. So 1 half squared is 1/4 times ln of 1. This is simply 0 because ln of 1 is 0. So this would be 1 times negative 1 half is negative 1 half plus 1 squared, which is 1. This should be 1 over 4. So if we solve for c here, negative 1 half plus 1 is 1 half. And then we have c over 4. Okay, if we solve for c, as you can see, cross multiply, we have 4 over 2, that is 2. Okay, and of course, if we're going to write the general or this particular solution, this should be our answer. Y squared ln of x minus xy plus x squared is equal now to 2y is squared. Okay, so this should be our particular solution. Okay, this should be our particular solution for our differential equation. So again, let's try to solve another problem. So let's try to solve number 4. Okay, we have y squared dx plus x squared plus 3xy plus 4y squared dy is equals to 0 when x is actually equal to 2 and y is equals to 1. Okay, as you can see here, this should be our m, this should be our n. So as you can see here, we have a simpler m. So if we let x is equals to vy, we are letting dx as v dy plus y dv. Okay, so m is simpler. So let's try the substitution. So we have a y squared. Our dx should be v dy plus y dv. Okay, plus x squared vy y. So we have v squared y squared plus 3 times x, which is vy multiplied by y, plus 4y squared dy is equals to 0. So what we did, again, we substitute this substitution in our original differential equation, homogeneously. So that if I'm going to simplify, we have vy squared dy plus y cubed dv, okay, plus this should be v squared y squared plus 3vy squared, okay, plus 4y squared dy is equals to 0. Let me rewrite it again so that we can see it clearly. Okay, so I'm going to distribute dy here, v squared y squared dy plus 3vy squared dy plus 4y squared dy is equal now to 0. So can we simplify? Yes. B squared y squared dy. I don't think so. Okay, can we simplify? Any other third term here? Okay. So I think we cannot because we have by squared dy. Okay. This one. 3by squared dy and 1by squared dy. So we can simplify 3by squared dy. So 3 plus 1. So this is 3by squared dy again. And by squared dy. I'm so sorry. So that should be 4by squared dy. Okay, is there anything else we can simplify? No. So we have to copy. So this should be 3 plus 1. This is the equivalent. So we have y cubed dv plus v squared y squared dy plus 4y squared dy is equal now to 0. Okay, so the next thing to do is if we can simplify this, factor out some variables in here, so we must do that. So as you can see, all of the terms contains y squared. If we split off y squared here, still y squared. Y squared times y is y cubed. We have y squared, we have y squared. So if I'm going to multiply this or divide this by y squared, so what will happen is that we're going to have what? We're going to have 4v dy plus y cubed divided by y squared is y dv. So plus v squared, okay, dy plus 4 dy is equals to 0. And if I'm going to combine like terms, you have y dv plus, okay, we have v squared dy plus 4v dy plus 4 dy is equals to 0. Factoring out dy in here, we have v squared plus 4v plus 4 dy is equal now to 0. Is this a variable separable? Yes, variable separable. So, if I'm going to group all of the terms in v in this dv, so we have v squared plus 4v plus 4 plus we have dy over y is equals to 0. And the next thing, again, our favorite part is to integrate both sides of our equation. So what will happen here is that, what? So we can rewrite this as dv over v plus 2 squared, okay? Plus integral of dy over y is equals to 0. And again, if we let v plus 2 as equal to u, get the derivative of u with respect to v, that is still dv is equals to du. Okay, so what will happen? We can substitute simply, okay, dv is equals to du, so this is du, and our u is v plus 2, it is raised to squared, so it is u squared here. Okay, so plus integral of dy over y is equals to 0. So if we integrate this, we know that this should be u raised to negative 2 plus 1 over negative 2 plus 1. Okay, plus the integral of dy over y is ln of y, constant of integration, equal to constant of integration. So we have what? Negative 1 over u plus ln of y is equals to c. Negative of 1 over u. Okay? So, let me just rewrite this. ln of y minus 1 over u. What is our u? Our u is v plus 2. So, v plus 2 is now equal to c. Okay? Okay? Are we done? Yes, not yet. Okay? Not yet. We're not yet done. So, as you can see here, we already have a simplified expression, but the b plus 2 is still needs to be substituted back. So if I'm going to multiply this whole side of our equation by b plus 2, what will happen? We have b plus 2 multiplied by ln of y minus 1 is equals to c times v plus 2. Okay? But again, in our substitution, diba, we let x is equals to vy. So v now is equal to x over y. So if we substitute back, okay, the v, so we have x over y plus 2, okay, ln of y minus 1 is equal to c, okay, x over y plus 2 here. Simplifying, we have x plus 2y over y, ln of y minus 1 is equals to c. Still the same. Okay, so we have x plus 2y over y. So if we multiply both sides of our equation by y, so what will happen? So the y's will cancel. We have x plus 2y, okay, ln of y minus, of course, y is equals to c x plus 2y. Okay? So, that is our what? That should be our general equation. So, this is our general equation. But that is not our final answer because we are given a certain general equation, I mean general solution. Okay? But still, we have a condition that at x, find the DE when x is 2 and y is equals to 1. So if we substitute that, 2 plus 2, okay, because 2 times 1 is 2, times ln of 1, okay, 2 times plus 2 times ln of 1, which is 0, is still 0, minus 1 is equals to c, okay, 2 plus 2. Okay, we simply substitute the value of x and y here to find c. So negative 1 is equals to 4c. Then c is therefore negative 1 over 4. And if we're going to go back to our equation, our answer should be, so our c now is negative 1/4. Simply substituting back to our general equation, we have x plus 2y, ln of y minus y is equals to negative 1 over 4, x plus 2y. Okay, multiply both sides by 4. We have 4x plus 2y, ln of y minus, we have 4y here. Okay, and we have negative of x plus 2y here because the negative sign is retained. Okay, so what are we going to do here is simply we have 4x plus 2y, ln of y minus 4y is equals to negative x minus 2y. So if we combine like terms such that we transpose this on the other side of our equation, we have negative 2y plus 4y. We have an answer of 4 times x plus 2y ln of y is equal now to, we have negative 2y plus 4y is 2y. We have minus x here. So this should be our particular solution and our answer for this problem. Particular solution. Okay? So down to our last problem. Okay? So we're going to solve this homogeneous DE with a given certain condition. And as you can see here, M is simpler. Okay? So we have to let, okay, let x equals to Vy. Then we have dx that is equal to v dy plus y dv. Okay, rearranging this, I'm going to simplify first. by distributing 2 inside the function. So we have xy dx plus 2x squared plus 4y squared dy is equals to 0. So then we simply substitute again. The x is equals to vy and dx vdy plus y dv. Okay, if x is equals to vy times y is vy squared multiplied by dx. We have vdy plus y dv. Okay, plus twice the squared of x, which is vy, so that is v squared y squared plus 4y squared. Okay, dy is equals to 0. So if I'm going to multiply this by this, so vy squared times vdy, that is v squared y squared dy plus vy squared times y dv is vy cubed dv plus 2b squared y squared dy plus 4y squared dy is equals to 0. Okay? So, what we're going to do here, combine like terms, b squared y squared dy, then 2b squared y squared dy, we have 3b squared y squared dy, okay, plus vy cubed dv plus 4y squared dy is equals to 0. So we combine this and this. It turns out to be 3b squared y squared dy. And as you can see, we have a common factor inside of our equation such that we can multiply both sides of the equation by 1 over y squared, or divide whole side of our equation by y squared. So what will happen here? We have 3b squared dy plus vy dv plus 4dy is equals to 0. So rearranging this equation such that if we're going to group them, okay, we have vy dv plus 3b squared dy plus 4dy is equals to 0. If I'm going to factor out, okay, if I'm going to factor out dy in here, so we can have 3b squared plus 4dy here is equals to 0. So as you can see, this is a variable separable. We have dv here, we have a dy here. We can separate all the terms containing v on this side of the equation and all the terms containing y in this side of the equation. So such that, right, we rearrange that. So what will happen? dv v dv over 3b squared plus 4 plus, okay, dy over y is equals to 0. So to look it, for it to look nice, I would try to rewrite this dy over y plus v dv over 3b squared plus 4 is equals to 0. And if I'm going to integrate that, because that is a variable separable dE now, okay, this should be simply dy over y, simply ln of y. And in this integrand, okay, if we let u is equals to 3v squared plus 4, if we differentiate u with respect to v, we get du over dv, that is 6v, and du is now equal to 6v dv, of which you have v dv here. Okay, I'm going to offset 6 here, and of course outside of the integrand sign, the reciprocal. So what will happen is that I have plus 1 over 6 integral of 6v dv, which happens to be du over u, is equals to 0. And if you integrate that, that is simply ln of y plus 1 over 6 ln of u, okay, is equals to c. So because we integrate also this, the integral of 0 is c, constant. So we have ln of y plus 1 over 6 ln, but u is equal to 3b squared plus 4. So we have 3b squared plus 4 here is equals to c. And for our equation to look neat, we can multiply both sides of our equation by 6 just to eliminate the 6 there. So we have 6 ln of y plus ln of 3b squared plus 4 is equals to c. And by properties of natural logarithm, we can rewrite the 6 ln y as ln y raised to 6 plus ln of 3b squared plus 4 is equals to c. And by properties of again of ln, we can rewrite this as ln of y raised to 6 times 3b squared plus 4 is equals to c. And if we try to exponentialize, okay, exponentiate both sides of our equation for us to eliminate the ln sign, okay, we can rewrite this as y raised to 6 times 3b squared plus 4 is equals to c. Okay? So this is our general equation. But according to our problem, okay? According to our problem, we have a condition right here. And our condition is x is equals to 0, y is equals to 1. So, okay? So, if x is equals to 0, y is to 1. But before that, first, we let x again, a while ago, is equals to by. So, we need to get v. So, that is x over y. Okay? Before we can get the particular solution. So, we have y raised to 6 over 3b squared. That is x squared over y squared because v is equals to x over y plus 4 is equals to c. So y raised to 6, 3x squared over y squared plus 4 is equals to c. And simplifying it furthermore, okay, if we simplify this furthermore, what happens here is that we have y raised to 6, 3x squared plus 4y squared over y squared is equals to c. So this should cancel, y raised to 4, y squared would cancel. And that should give us, okay, that should give us a general equation of y raised to 4, 3x squared plus 4y squared is equals now to c. Okay? So this is our general equation. But our condition is that we need to find the particular solution when x is equals to 0 and y is equals to 1. So what do we need to do is to simply substitute to find the value of c. So 3 times 0 squared, so this is a 0, plus 4 times 1 squared is equals to c. So 0 plus 4 times 1 is c is now equal to 4. Hence, our particular solution would be y raised to 4 times 3x squared plus 4y squared is now equal to 4. So this should be our answer for our homogeneous differential equation in this problem. This should be our particular solution. Okay? And that's all, guys. So thank you so much for listening, and please don't forget to subscribe and share my channel also for those who are struggling with their differential equation subject. So thank you so much, and God bless.